Hello everybody, it's Damon. Crazy Logics 007 on YouTube, Crazy Logics most everywhere else. Back to this Aurora amp. Uh, if you've watched the previous videos on it, hopefully this will be the last one. We tried to troubleshoot the subwoofer outputs. We had repaired the power supply, which is actually a dual power supply. I'm assuming one power supply maybe runs the 4 channels and the other power supply runs the subwoofers. And so we tested and we had the 4 channel amp working, but we wasn't getting output on the subwoofer channels, which we should be now if that was the dead power supply part. However, part of whatever is keeping this subwoofers from working may have been what caused it to blow the power supply. So we need to look at that. So I'm going to look at the cover here, and it goes on that way. So the sub channel is these 2 terminals on this side. So we need to figure out which FETs, because we didn't have to remove any of this or anything, are for the sub channel. And so that's going to be these 2. And so we're going to get our meter. I'll set it, well, kind of got us zoomed in here so we can see more of the board a little bit, but I'm going to put the meter on continuity. And so this stud goes to there, and that stud should be there. So we can go and, trace this line back, and it goes here, and I believe that's a jumper to there. Yep. Goes along here, and it goes to each of those pads. That should be the emitter resistor. Big, yes. So these are big triple leg emitter resistors, which basically means there are 2 resistors built into one. So if I'm back on, we were on this one right here. So we came, and what was it here? Yeah, there and there, which takes us up to this FET, and this one jumps over probably there. Yep. So there is the subwoofer FETs on this leg, and so this one, well, it should be this one. Except we're not getting anything. Okay. And hang on. Well, first of all, let's see here. So that, if what I'm thinking's right here, I think we got a break. That goes to there. Am I following that right? Oh, this one. That one goes to there. Yeah, that goes to that other emitter resistor, ends up going to these. So these pairs are the subwoofer. Remember, we didn't have any dead output FETs. None of them checked shorted. But what we just found was continuity goes away here, and I can see a little reflection. Let me do a little inspecting here, just a second. I'll try to keep my big fat bald head out. Yeah, okay. So I've been working on my cameras. I had some problems. Let's see if I can get this camera over here. I bought this camera used off Marketplace, thought it was giving me some issues. Tried a whole bunch of driver stuff. That all didn't work. It was still screwing up all my videos, making them choppy, making them terrible. Then I got the realization that I was plugging this camera in the same one as this camera that you're looking through now, and they're the same one. They were both going into my USB 3.0, and that's when everything would freak out. I had another camera right here, this smaller webcam, plugged into a different USB 2.0 port that was doing my capture of my oscilloscope. And so I decided I'd try plugging this one, unplugging that other one, plugging this one in, and see if being on different USB channels would fix it. And it did. And so I've been playing around with the USB stuff, and I've discovered that most likely it's that you can only have one camera per USB setup, and I'm not sure if I have enough separated out USB ports to run 3 cameras. I may be stuck at 2, so I may have to look into getting a video capture card to be able to go any more than 2 cameras right now. But I did get this one working. This one's 1080p where the other one's 720p, and I'm going to use my magnifier. My microscope, while it works on good flat boards and stuff, when you get stuff high up, sometimes it has a problem focusing. There's not enough clearance to really look in the middle of the board. So I did try this little experiment. Let me see if I can get this held right. And we'll switch over to this camera. Here we go. And I need to get a pointer. Here we go. So this right here, oh, I've got it turned the wrong way. Let me turn this where it moves with my hand correctly. Ah, there we go. So this is that leg, and here is the little break. And you notice it's where the thickness of the solder actually goes to the thin part. That's the thick part of the solder they had up here, and it went there. And then as I was looking, that's just what I was looking at, there's a little crack here. I see a little crack down through here. And there's a little crack along this edge that's exposed that copper there. A little crack there, and then you can see the crack. Which way does it go? Oh, right there. Goes up. That's it right there. So let me switch back to that. So here's what I assume has happened. At some point, this amp has either A, been dropped, or B, more likely, been mounted up in a car and maybe not been securely mounted and slid around and hit this. It's either been dropped on this terminal or something's hit it. It slid around. This has been whacked. Or like if this was mounted in the trunk and something heavy rolled into it or smacked into it, slid into it. And what has happened is because this is big and huge and beefy and it's all soldered here, that's one big chunk. Whenever that hit, it's flexed this board and caused hairline fractures. And what we need to look at, and I'll have to pull it off the screen here because you don't want to see my fat head. We'll look at it if I find something here. And I am not finding anything here. Let me get my flashlight real quick. I want to make sure. So what I'm looking for is cracks on this whole side of this board. Has got like a ground plane to it, and sometimes a few things attached to it. But I'm looking all through there. This is where that area was, to see if there's any cracks here in any of this, and there's not. So what that tells me is that when this took its whack, it just flexed this board, and on this side it put a stress crack on the copper foil that was along all this. So it didn't hurt the board's fiberglass. It's got enough flexibility to handle it. It didn't flex enough to hurt the other side, the copper foil, so it's only flexed enough in one direction that it's created a hairline crack. And this is through a whole bunch of other stuff besides the speaker terminals. It goes to here. Here's where it ends. It starts over here, so it's right here at this speaker terminal area. And it actually is right here where a couple of these mounting holes are for this plastic. So it followed the path of least resistance from this big solid chunk area and flexed right there. And so what we've got is it put stress cracks in those traces. And some of them are working just fine because I can see where the crack probably goes that way, right there. But that's through a thick solder area. So even if it stress cracked the copper trace underneath, that solder has got it covered all through there, so we're not losing any connectivity. Now, it probably needs to be reinforced, and I'm going to reinforce all this. But all that means is that the reason why the subwoofer channel probably was not working is that there's a stress crack right there, and it probably worked for a long time. You know, vibration, and over time, just a little bit of flex here or there or whatever slowly made this crack open up enough that there's not continuity that we were seeing with our meter. You know, we were just trying to figure out which, let me get this up into the camera a little better, which FETs were driving, you know, each part of the subwoofer, and we noticed that there is no continuity here. And I'll bet, yeah, I've pushed down on the board and flex it back in just a tiny bit. That makes connection. So whoever had this amp before probably never noticed that it had a problem until it finally just stopped working one day. Probably when it blew the power supply, or these power supply FETs. And there's a good chance that since that's cracked right there on that sub channel, if these are the sub power supply, that if they were rock and rolling it hard and this disconnected the sub all of a sudden and then reconnected it all of a sudden, big power spike, and then it's a battle. You know, you get this giant current rush, and you know, you got these big old FETs that are the actual output drivers, and you got these smaller FETs that are on the power supply side. Well, if you are given, you know, suddenly in-rushing you know, given a big current rush of power because the subwoofer gets reconnected all of a sudden, whichever is the weakest link is going to pop, and I'll bet it popped one of these FETs, which once you pop a power supply FET, normally because of the short it creates, it'll pop some more before your fuse dies. You know, and so I can't remember. I'd have to go back and look at the videos if all the FETs were dead on this side or if there were some of them that survived, if only a couple died. But we replaced them all with a match set. But that's really good news because I almost 99.9% guarantee that's why this wasn't working. And all we need to do is get some good wire. I like to use the braid. Do I have any small wire already up? Yeah, it's stuck back here. So I got heavier wire, light wire I use, and then braid. And we just need to clean up the solder in these areas and go through and jumper anywhere that stress crack might have been. And even if it's working, I'm going to go ahead and jumper it because I want to make sure that where that stress crack was, it can never over time vibrate enough to crack up through the solder and tear it up somehow or get disconnected. It's really telling that the crack happened to be where this thick solder went to thin, and that's the one that disconnected, whereas I'll bet all these others, yep, because I can see a little place. All these others are just fine and dandy. Except this little bitty one. Where does it go here? Oh, that's the protect light, and I'll bet that's part of the light. So they may not even seen it. So we're going to have to fix this little crack here and here, and that's where it ends. So I am going to go on ahead and I think I'll stop the recording. Maybe we'll do one here. Let me show you how I would do a couple of these. Let's get this right here. Boy, you can't hardly see that. What if I get it way down here and I flip this thing around? Can we see? Will it let me adjust? Has that crashed it already? Oh, okay. Okay, so we got a tiny bit of zoom in here, but man, you really can't still see that. So we'll probably do most of these off camera here because nobody wants to just see that. If you guys want to see that, put it in the comments that you want to see that. I would take my little broken X-Acto knife here. I'm going to get my glasses, and we will look about scraping. The blue color on this is called solder mask. Oh, there's a solder joint that needs fixed too, and I just noticed that. I'm gonna give this whole board a good once going over, but I see a little solder joint back there, and I don't know what was there. But that's definitely something I need to go. So this whole thing kind of needs a going over then. It may have had some vibration to it at some point. But we'll scrape away a tiny amount of the copper there, tin it up, and I'll take my tiniest copper wire, since this is just a super thin. Let's see if you guys really need to see this so you know what we're doing here. Kind of like I did on that Rockford 150S. If you watch that video, I think I got zoomed in enough on it. I'm not entirely sure, but let's see. Yeah, here we go. This is helping a whole lot. So I would take, and I'm going to scrape a little of this away and jumper that with a piece of wire. Always, never just do it with solder. Always do it with a piece of wire. This one right here, since that, depending on if I can get that wire to lay in there, maybe not. Otherwise, I'll switch views here. You know, I've got some old solid wire Cat 5 cable that I cut up and pulled out, and so it's actually solid wire. I can always use it with a tiny little solder right there and leave the insulation on and bend it and bring it around to the right spot and solder it into the right spot, and then use a little dab of E6000 to hold it in place so it doesn't ever vibrate free. So you can repair traces that way. One neat thing I like to point out is you can buy this stuff called the solder mask. It's high temperature. It's a 2-part epoxy type stuff. And you can buy it in green, red, blue, black, and I think yellow. So if this amplifier happened to be one that was had like a plexiglass back where you can see it, or you were doing repairs on this side, which would actually be the side they'd probably have the plexiglass on, but if you needed to do a repair, you can repair traces, get solder mask, and repaint it on to match so that it blends in super well and most people can't see it. You can get copper foil to replace traces and stuff, and if you take your time and do it all, you can make it look like it never happened, basically. So that, like I said, if it was a display one that had the stuff, that's what you'd do. Some people do that for high-end electronics or classic electronics that are very valuable, and so they want all the repairs to blend in and look like they never have been there. This amp's not a classic or collector or anything. People want this thing to work, so I'm going to make sure I put in, you know, use some of my heavy braid to repair these traces, and I'll. Where's the one that we have? This is the bad one right here. So you notice this braid is about the right stuff. It's much thicker than the actual copper trace as far as the amount of copper. So I'm going to put that much in there to repair that, and that'll never do it, and I'll get it heated down in there so that'll take care of it. And I'll come back once I've kind of got this all done, and I'll show you. We'll use the little zoom in cam, and we'll go over it. Like I said, make in the comments, you know, if you want to see some of that. I'll try to do it on one that maybe where we only repair 1 or 2 traces, like I did in that one Rockford video. This is a whole bunch, so it's going to get my fat head in the way and everything else, and so I'll get them all done, and then I'll show you each one of them. But we're going to repair everything that goes across there, even if it's still making continuity or not, because that's going to ensure that it'll be repaired forever and it never has to be an issue again. So I think that's important, because I don't fix stuff, you know, janky, I like to fix it permanent, and that way it's good to go. And that should fix this channel. And so on the next video, once I show you that, hopefully I'll have some wires hooked up and we'll show that the subwoofer channel's working, and then we'll put this sucker back in the case and I can do my final endurance tests and everything, and it'll be good to go. So, all right, we should have a little quick transition here and you should see the next part. All right, I have got all these repaired. I'm going to show you that, and I'm getting prepped. I'm going to go ahead and show you a couple other little things. I'm pretty confident this will fix it. But let's go ahead and get the cam zoomed in. Here we go. I have added copper traces anywhere there was a crack. So there, got braid in here, and every one of these I pushed in deep into the so where the repair copper is touching the original copper trace all the way through there. Did some little repairs on any little trace, and there you see a big one that we did. And get back to full work here. And so I also went through and checked all around here. Some of the solder connections didn't look as good. Maybe some of them were stressed a little. This amp might have had a little vibration damage. Remember, we had to fix a leg trace here for this one FET that was still all good on this power supply, but it was not in good shape. I noticed a crack, so I went through and inspected all of these and actually touched up, using my little thing, and then actually touched up some joints that just wasn't happy with, didn't like. Found a couple places I wanted to fix it up, and just kind of looked the whole board over. It didn't look like it really had vibration damage, just not perfect, from the factory. Sometimes the solder joint will be just barely okay, and I just wanted to make them nicer. If I haven't shown it in enough videos, I want to show. I'm getting ready to. I've got my piles of insulators, and I've cleaned them. You can see that was nice and clean. And then, so to prep a surface, you clean it off, and then just a thin skim coat of your thermal compound, and it needs to be thin. Thick does not help, actually. In a perfect world, it'd be, this would be perfectly flat, the heatsink would be perfectly flat, and they would touch and transfer all the heat perfectly. Well, that don't happen. Plus, we can't have the electrical connection, so we need just the tiniest thin amount to go where that's going to go. And so when you press it, you notice how the thermal paste all squeezes out, and it makes a nice. Let's see if we can position that a little better. These are all in the midst of cleaning. It'll smash out. You still got thermal paste where you can see it. And then I'm going to go ahead and lightly skim coat the back of this, because this is what's going to touch the heatsink. And that's going to fill in any microscopic voids in the heatsink. And we're going to get them all squared up and perfect. And I'll do all of them that way. I'll wipe these all down, make sure they're all perfectly clean. And that, once they're all done and ready, it'll be ready to set down into the board, and then we can start putting the clamps on. But that's all you have to have. You're just filling in the voids and providing good thermal contact. You want it to squeeze out just gently. And that's exactly what we did. We've got all this repaired now. And when I transition over into the next scene, hopefully this should be setting in the case, and I'll have the wires hooked up, and we'll test all those channels again. But I'm pretty confident that was the issue on the subwoofer channel, to the point because none of this was blown over here. All this seemed to work. We just didn't get any output over there on that first test, and when I found that shorted trace, that would explain, because one leg wasn't even connected. So like I said, cleaned up a little bit of that. Doing this right now. We'll get this thing back in the case. We'll give it a quick test, and we'll call this done. That's why it always pays to inspect everything really well and trace stuff back. So I'll see you in just a moment. All right, we are back. We got it all together, ready to do the test. One thing I screwed up, I was going to show you using deoxit. I'll show it, make sure I show it in the other videos, but I always on the all the switches and all the gain pots and freight crossover pots and stuff, put a little deoxit in there, work them back and forth, work the switches and everything, get them all clean, and then go back with some rubbing alcohol or acetone and clean the board itself off, but leaving the deoxit in there. If you're a musician and like plays electric guitar or bass or something like that, or got foot pedals, something like that, you probably already own some deoxit because you keep your stuff conditioned with it. If you don't, if you know a musician, you might be able to borrow some. This stuff's not cheap, but it works wonders on switches and stuff. It cleans them. You don't want to leave it all over the board. I always clean everything up around them, but it actually does do it removes the oxidation, you know, cleans up all the contacts and stuff inside. It does leave kind of a sealant or a protectant in there. You'd be surprised how many times I've fixed an amp for a friend that was screwed up doing staticky weird stuff. You know, he was trying to get his bass boost right or something. It was all messed up, and cleaning with some deoxit, and suddenly it's like brand new again. So really important to do. I do that with every amp, no matter how new or old, just because you never know if somebody splashed cola up in where the adjustments are or something, and you just want to get it cleaned out. So we've got it all back together. Let's switch to the little small screen. Let's power it up. We are powered, and bam, we got green light. That is good. And let's turn on the music. Out of the sub channel, and that's the one we've got hooked up. We go over here and over here. That's the channel we did not have any sound coming out of, so we are good. I've got everything buttoned up, like I said. Turn off my power supply. It's probably noisy. I've deoxidated everything. I've got everything all nice and done. So now I can put the cover back on, and I will then go through and do my normal sound quality tests on all the channels just to make sure they sound good. The subs channel obviously already does sound good, and then I'll hook up the big wires and go to my resistive load and give it a bit of a burn in. It's going to be a time consuming on this because I want to check each channel real good. Even though we didn't have really any problems, I'll give each channel probably a 5-minute test and then probably a 10-minute test on this sub channel, just feeding it. And the way I do that, and I'll show that eventually in one video, is I hook it up with my bigger wires with a bigger fuse for what it's rated, like this one, closer to what it's rated. I hook up the resistive supply, and then on the RCA in over here, I will just feed it a test tone, so like 60 hertz for the sub channel, 5,000 hertz for the other channels here, and just let them go. And that big resistor makes it nice because then it's not making a ton of noise and playing real loud or whatever. But I'll crank it up, watch on my oscilloscope, make sure we're not clipping. On big amps, I test it. I'll bring it up to a soft clip and then slightly turn it down, and then just let it sit there and cook for a little while. And that ensures that we've got good thermal protection. Anything else that goes wrong, it gives it a good hard test. The other thing I do is when I am running these, a lot of times I'll go through and do a little pokey poke in areas of the board and stuff like that to make sure there's no other goofiness. Be careful of not sticking your fingers between higher rail voltages on bigger amps, but you can always get a plastic spudger and give it a little push here and push there and stuff. I'll do that while it's playing either through the speakers or even when it's doing the sine wave, because I can have the oscilloscope hooked to the output. I can see if there's something goofy goes on the wave, but that's just to double check. This one I'd already checked all the circuit board connections, but it's a good idea to do. Just to make sure you didn't have vibration damage, especially if it's not your amp and you don't know if it's ever been mounted to a box or what its life is. If you've owned it all your life and you know it was always mounted with some rubber feet into a good secure location, it's probably okay. But I always give them all that good pokey poke test just so that I know everything's good and solid. And like I said, I'll give this the little bit of endurance test, and it should be ready to get out here. I got several people wanting a 5-channel amp that have asked me if I had one laying around, and I said, yeah, almost. I just got to finish fixing it because they're wanting to do a little installing. 5-channel amps are kind of nice and fun because you get your fronts and your rears and your sub all in one amp. You only have to run one set of power wires and stuff, and you can set everything on them, and so they're pretty nice for an all-in-one upgrade to an old junky factory plain Jane system, all in one shot, and you can get some real nice sound and rock and roll pretty nice in your car. So like I said, thanks for watching. If the video helped you, or if you enjoy this sort of thing, subscribe. I really enjoy seeing that people subscribe because they want to see more. We're going to have more Rockfords, more old school amps, more new amps. That's what we're going to do. And then comment on this. Ask questions. Go to the other videos if it's something that you happen to be really interested in. I don't even mind if you kind of just put a little list that says, hey, this is the amp I got that's dead on me. Do you have anything similar? And that way I can reply with something I do have similar, or if it's the exact same thing. And I can say, look forward to that. I'll try to put a guesstimate, well, it's going to be a long time before I get to that one, or hey, that one's coming up, here shortly. That's one of the ones that's real quick on my list. So, like I said, if you got one that's dead that you're wanting to play with, I don't recommend you playing or learning on good quality amps that you really value. I'm going to do a small video series on setting up your own little test bench and how you can kind of get into a little bit of repair, and it's going to talk about how to pick up some junk dead amps and some of the not very valuable brands for free to nothing kind of cost, or super low cost, so that you can learn and you can play and you can test and learn to do this stuff. Because I've been doing all this for more than a year before I even started my first recording of them. So I'd got some experience and stuff, and I have a little bit of electronics background anyway. But like I said, thanks. This one's working, and thanks for watching, and comment, subscribe, all that good stuff, and I hope to see you in some of the other videos, and be good.